Hello and welcome to another exam paper walkthrough. Today we're looking at the Corbett Paper 2, Paper 3 preparation paper. So it's all based around possible topics that could be on Paper 2 and Paper 3. Really good, really deep, lengthy paper. I'm doing this in front of a live studio audience, in front of my full Year 11 group. And we'll see how this goes. So it's broken down into kind of three areas. Star topics, these are highly likely to be on your paper. We've got then other unseen topics or more usually prominent, and then the final section is seen topics. So these have been seen, but they may well appear more than once. Okay, so question one. Supermarket sells baked beans in two different can sizes. Okay then, so question one. Supermarket sells baked beans in two different size cans. We've got 40 pence for 215 or 74 pence for 375. Which size of can is better value for money? So I'm going to write down the two sums that I'm going to work out on my calculator before I even touch my calculator. So I'm going to do the price per pence. So if I do for 215 divided by 40, and I'm also going to want to do 395 divided by 74. So the first one gives me 215 divided by, type it as a divide or as a fraction, but as a decimal that gives me, for every 1 pence, I get 5.375 grams of beans. And for the second one, for 1 pence, I would get 395 divided by 74. Just double checking my typing. I would get 5.3378 grams per pence. So which one is better value for money? The one that you get the greater amount for each pence. So actually the small tin is better value. So the 215 gram tin is better value. Question two. Actually, okay, for question two, James receives two job offers, a job in Milan and a job in Boston. The exchange rate is, and you're given the two exchange rate, work out which job has the highest salary. So even though both are in a different unit, I'm going to convert them both into pounds. So to do that, the job in Milan, so M, is going to be worth 55,000. And we'd need to divide by the exchange rate, which is 1.25. And for the job in Boston, I need to do a similar thing, but this time 64,000 divided by the exchange rate, which is 1.42. Interestingly, it's written in a way to try and catch you out. You're given the job in euros first, but then the exchange rate in dollars first. So watch out for that. So 55,000 divided by 1.25 gives me the job in Milan would pay £44,000 per year. The job in Boston would pay 64,000 divided by 1.42 would give me £45,070 and 42 pence. So which job has the higher salary? The job in Boston. You could have, and a few probably arguably stronger students would have tried to convert them into, so for example, I could have taken the job in Boston, I could have divided that by 1.25 and then times it by 1.42 and compared them in dollars. It doesn't specify what your comparison has got to be in. I would always go for the simplest one on the paper. Doesn't mean that you'll get it wrong if you go any more complicated. It just means your exam marker is going to have to spend more time going through your solution. So I would always go for the most likely, unless there's a shorter version. Okay, lowest common multiple of two numbers. There is a really nice kind of hack on your calculator you can do for this. If you type the two numbers in as a fraction, it will automatically cancel it down for you. And that gives you two pieces of information. The first one is whatever the fraction has been cancelled down by would be the highest common factor. So you can see that the fraction has been cancelled down by 12, so that would be the highest common factor. And to get the lowest common multiple, you cross multiply one of them. They'll both give you the same answer, but you could either do 60 times by 6, 360, or the other way around, 72 times by 5 would also give you 360. On your calculator, that's quite a useful hack. So your calculator will automatically cancel it down. What it's cancelled it down by would be the highest common factor. And then you would cross multiply one of the numerators by one of the denominators to get the lowest common multiple. Okay, question 4 then. Express 108 as a product of its prime factors. And again, on a calculator paper, 3 marks, but I'm going to do it like this on my calculator. Your calculator will automatically do it for you. Unless it says, show how you did it, you can, if you get 108, and then you press Shift and Fact, which is on this button, the time function, Shift, and then Fact, it will automatically convert it into a product of its prime factors or convert it into index form. So 2 to the power 2 times by 3 cubed. So again, what I've done there is 108 fact. That's all I would do in an exam for that question on a calculator paper. I've shown there what I've actually done on my calculator. So 100, just to show you again, 108 equals, we've got it as our form and we want to change the format of the number into its factors. You press Shift and then you can see the factor written above the time function. When you press that, it converts it into its standard form, into its index form. And then, like I've just shown you, to find the highest common factor of 2 numbers, the easiest, most straightforward way on a calculator paper is to type it in as a fraction, and it will automatically cancel it down for you. And what it's cancelled it down by is the highest common factor. Don't tend to show you that because those questions will often appear on a non-calculator paper and you will need to break them down to their prime factors. You'll need to do Venn diagrams to show and it would be the intersection of the prime factors. But on a calculator paper, there's nothing to stop you doing that. It's a very straightforward way. Write this number in standard index form. Again, we could use our calculator, but I'm not going to bother because it actually puts your calculator in a format that's not very helpful. In effect, we can't. We moved the decimal point from there to there, so we count how many places we've moved it. 2, 4, 6, 8, 9, I believe. 2, 4, 6, 8, 9, so it's to the power 9. Write as an ordinary number. If you've got a minus, it basically means you put 4 zeros at the front. So it becomes 0.0000, 4 zeros at the front, and then the number 8024. And then the final one, work out the value of W, giving your answer in standard form correct to 2 significant figures. So I'm going to do this on my calculator. I'm going to change this slightly. I'm going to say that W is equal to the square root of CY. So 2.2 times 10 to the 6. I've not typed that in very well. Times by 6 times 10 to the 5. Divided by C minus Y. So 2 times 10 to the 6 minus 6 times 10 to the 5. And I would just type it into my calculator like that. So provided I type that in correctly, there's nothing wrong with that as a format. So square root of a fraction. Type it in using standard index form. So 2 times 10 to the 6 times by 6 times 10 to the 5. And I've not pressed the times 10 to button, times 10 to the 5. And I want to divide that by 2 times 10 to the 6 minus 6 times 10 to the 5. And provided I've typed that incorrectly, I can get the full marks just for that. So I'm looking at 925.8200. So to 2 significant figures, that's going to be 9.3 times 10 to the 2. Provided I've typed that incorrectly, anyone spot any mistake that I've made? Feel free to let me know. Okay, question 6. Harriet's travelled from B to C. Her average speed was 58 miles per hour. The traffic on the return journey, her average speed is reduced by 23%. So if we're looking at 23% reduction, it means so 23% reduction means in effect we've got a multiplier of 0.77. So for that question, all we need to do is 58 times by 0.77, which should give us, that sounds perfect, 44.66. It doesn't ask for a specific degree of accuracy, so there's nothing wrong with giving it as 44.66. Okay, question 7. Terry goes to the post office to exchange some money. We've got the exchange rates here. We've got dollars and euros again. And it says that there's a commission charged. Terry changes $651 and 161.2 euros into pounds sterling. The post office deducts their commission and gives Terry £528. What percentage is the commission? So we need to work out the total money that he would have made. I'm going to do that as a single sum though. I'm going to say that I'm after 651 divided by 1.55, just double checking that I've got my units consistent, and I'll add to that the amount of euros in pounds, so 161.2 divided by 1.24. So that'll give me the total money that he had available. So I'll type it in like that, 651 over 1.55, and to that I'm going to add on 161.2 over 1.24, provided double check everything I've typed in is correct. I can't see any issues, so that gives me the total money that he would have made as £550 is what he should have got. If he only got £528, then the percentage of their commission we can work out by saying we do the amount that they kept as commission divided by the original amount, which is 550, and I'd need to times that by 100. So that answer minus 528, and I've probably messed this up. I can't do that. So let me just retype that. I actually wanted that as a fraction. As my numerator, I wanted the last answer I worked out minus 528, and I want to divide that by the original answer, and then I want to times by 100. So 4%. So that equals 4. So the percentage commission is 4%. Okay, on to question 8. Nina invests £1,500 for 4 years at 2.5% per annum simple interest. Work out the total amount of money in the account at the end of the 4 years. So simple interest is different to compound. It means that it's not readjusted every year. So you work out the amount that's made in the first year and you would times it by 4 rather than put it to the power of 4. It also means that we can't really use the multiplier of 1.025 because that will give us the total in the account, not the interest. So to work this out, I'm going to have to do 1,500 times by that as a multiplier would be 0.025. I want to times that by 4, and then I want to add on the original amount, 1,500, and that would actually give you my answer as kind of a one sum. But you can understand the steps. So I take the original amount, I multiply it by the interest rate, which is 0.25. That would give me the interest for 1 year. I times it by 4 because I'm after the interest for 4 years, and then I want the total amount of money in the account, so I need to add on the initial investment. So I should have £1,650 in the account at the end of the 4 years. Right, for question 9, that's more like it. This is a compound interest problem, quite a nice kind of AO3 problem. Martin has some money to invest and sees this advert, Bank of Maths, double your money in 15 years. The average annual growth for your investment is 4.5%. Will Martin double his money in 15 years by investing his money with the Bank of Maths? He must show you're working. So, in theory, what we want to know is whether the initial investment times by 1.045 to the power of 15, we want to know whether that is bigger than 2x. So that would kind of imply that the money has been doubled. So we need that to be x times by 1.045 to the power of 15 needs to be greater than 2 lots of the initial investment. We can kind of simplify that, and we can just say is 1.045 to the power of 15, is that bigger than 2? So 1.045 to the power 15 gives us a value of 1.93528, which is not bigger than 2. So, will Martin double his money? Not quite. No, not quite. There is nothing wrong with, and you would still get the full marks if you kind of made up an initial investment and then worked out whether it would be bigger. But I would suggest that that's probably a more direct way of doing it. Okay, so algebraically that 0.209 can be written as 17 over 15. Not that it's overly important for this question, but I've been curious for a while about why it has to state show algebraically. I did think that you could do that as a division, but I found out quite recently that your calculator has got this recurring button. So just for interest, 0.3, and then I need to type that digit in as a reoccurring. 0, and then I need another reoccurring digit. And then I need another reoccurring digit, 0.9. I can actually type a reoccurring digit in my calculator and it will automatically, if I typed it incorrectly, which I haven't. It's because I should have put 0.9. There we go. It will automatically convert it for you. And I've actually typed that in slightly badly. Didn't have a 0 there. You can type a recurring decimal into your calculator and it will automatically convert it for you. You can't do that on a calculator paper because it says show algebraically, but that's why it states show algebraically. So I'm going to start by saying that x, the number that I'm starting with, is going to be 0.309 with the reoccurring on the 0 and the 9. However many digits I've got as a reoccurring pattern is what I need to multiply x by. So I've got a 2-digit reoccurring pattern, so I would go to 100x, and I would say that 100x would be 30.90, and I'm going to put 9s just so I've got the reoccurring digits. I'm then going to subtract one from the other, so I'm going to say that 99x is going to be equal to 30.9 take away 0.3 is going to be 30.6. Then I'm going to say that x is going to be equal to 30.6 over 99. And from there, however you want to simplify that is up to you, but you can use your calculator. So there's nothing wrong. You won't lose a mark if you jump from there to saying that x is equal to 17 over 55. If you want to, and I would probably recommend it, you include a working step just to show exactly what you've done. So if I kind of explain what I mean by that working step. So let's put that 6 better and then show the step. So I would, if I was doing this on a non-calculator, I would then say that x is going to be equal to 306 divided by 990. And then I would simplify it. So numbers that go into 306 and 990. And then how you simplify that down is up to you, but there's nothing wrong with going straight to 17 over 55 from there. So that's showing algebraically. That's really the algebraic part though. Break. Okay, question 11. A is a point with coordinates of 320. B is a point with coordinates 15, 2. N is a point on the line such that ANNB is 2 to 1. Find the coordinates of the point N. So, in effect, if we've got this ratio, that means 2/3 and 1/3. So all I need to look at is the difference between the coordinates to start with. So if A is the coordinate 3, 20, and B is the coordinate 15, 2, the difference between them, the difference is going to be 12 and 18, and we want 2/3 of that and 2/3. We want to add 2/3 to that, and we want to subtract 2/3 from that. So 12. So actually, the coordinate of n would be 2/3 of 12. No, sorry. I've kind of misexplained that. That's not going to be the coordinate. In effect, we want to look at something that is 2/3 away from 12. So 2/3 of 12 away from 3. So let me just kind of clear that up a little bit, because I've not explained that very well at all. So if I look at 2/3, so that's the difference. If I look at 2/3 of the difference, so 2/3 of 12 is going to be 8, and 2/3 of 18 is going to be 12. So that's the difference from this coordinate here. So the coordinate of n is going to be equal to 3 plus 8, and that's getting bigger, but the other coordinate is getting smaller, so it would be 20 minus 12. So the coordinate of n would be 11, 8. Okay then, the next question then, we're looking at question 12. Declan ran a distance of 200 meters in a time of 26.2 seconds. The distance of 200 meters was measured to the nearest 10 meters. The time was measured to the nearest tenth of a second. So work out the upper bounds for Declan's average speed. Well, speed is equal to distance divided by time. So we want the maximum speed, the upper bound, so I'm going to call that SU for upper, and I'm going to have to take the maximum to make it the fastest time. I'm going to make it the fastest time, I'm just in my head planning it. So we actually want this to be the upper bound for his average speed. So the upper bound for his average speed is we want that to be as big as possible, which seems a bit backwards, because technically speaking, if you want the best time, wouldn't be his upper bound, it would be his lower bound. But if we want the upper bound of his speed, we would need to take the upper bound of his distance and divide it by the lower bound of his time. So in this case, if the distance was measured as 200 meters to the nearest 10 meters, the maximum it could possibly be would be 205. And if his time is measured to the nearest tenth of a second, the minimum it could possibly be would be 26.15. So the upper bound for his speed would be fraction 205 divided by 26.15 gives me an upper bound of so the upper bound of his speed is going to be 7.839388. So to round that then, I'm going to go to three significant figures, so 3 decimal places. So I'm going to say that that's going to be 7.839 to 3 decimal places. Okay, question 13. Nigel measures the time t seconds to complete the race as 15.4 seconds. Correct to the nearest tenth of a second. Write down the error interval for t. So that's going to be, in effect, we're going to end up with that as our inequality. No, wrong way around. So let's just tidy that up. Our inequality symbols are going to be, we're going to have a value, and t is going to be greater than or equal to that value, but less than the upper limit. So if we're saying 14.5 correct to the nearest tenth of a second, the smallest that could be would be 15.35, and the largest it could be would be 15.45. So that would be the error interval. Okay, for question 14, expand and simplify. Whenever I'm having to expand 3 brackets, I will save the easiest bracket for last, because it just makes sense. So if I'm going to do it in this order, so I'm going to save the x plus 1 for second multiplication, and I'm going to do this part first of all, so the back 2. How you do that is up to you. You can do it using construction lines. You can use a grid for it. You can, if you've done it quite a lot, you can get used to the practice of saying that would be x squared plus twice. Plus this one plus this one, so minus 8x, and then this times this would be plus 12. So that's my first multiplied out. Again, you can use a grid for this. There's nothing wrong with that. I tend to write it as 2 lines, kind of a little bit like column addition. If I times this all by x, I would get x squared minus, x cubed minus 8x squared plus 12x. And then if I times it all by 1, I'm going to line it up underneath. That would be x squared minus 8x plus 12. And then if I kind of add those together in their columns, I've got 1x cubed. 8x plus 1x would be minus 7x squared. Plus 2 minus 8 would be minus 6x. And then we've just got plus 12. And again, if you want to use a grid for that, that's absolutely fine. I'm a big fan of the grid. I just tend to do it that way as a bit shorthand. Okay then, question 15. Factorise fully. So our highest common factor here is wy. So I take a wy outside the brackets, and then I need to times wy by w to get w squared y, and then I need to times it by y to get wy squared. So that will be my fully factorised. Okay, for question 16, again, we're looking at factorising, so we don't need our calculator for this. So factorise y squared minus 13y plus 36, so that's going to go into 2 brackets. Both brackets are going to start with y, because that's the only way I can create a y squared. Then I'm looking for 2 numbers that multiply together to make 36, but that add together to make 13. And then looking for numbers, it's going to be two negative numbers. It's going to be minus 4 and minus 9. So my brackets would be y minus 4 and y minus 9, either way around. Factorise, slightly more complicated one, because we've got 2w squared, but the only way you can make 2w squared is with a 2w and a w. I tend to use the same format. I'm looking for 2 numbers that times together to make the back number, but because of the 2 lots of one of the number plus the other number need to add together to make the middle term. So if we're thinking 2 and 2 don't work, 4 and 1 do work, 4 and 1 that way around. And then if I look at, I need this one to be negative, and I need them both to be negative. So I'm looking at the minus 4 going in the bracket opposite the 2, and the minus 1 going in the bracket with the 2. Okay, and question 17 then. So solve. This is quite a not a difficult one. If I want to do this, I would times through by the 2 fractions, this and this. The reason being that will cancel all of my fractions in the question straight away. So if I times through by x plus 3 times by x plus 1 on both sides of the equation, that will automatically cancel out all of the fractions within that question. So if I times this first fraction by that, in effect the x plus 3's would cancel, so I'd just be left with x plus 1. If I times this fraction by that multiple, the x plus 1's would cancel and I'd just be left with x plus 3. And then I'd be left with 2 lots of x plus 3 times by x plus 1. Going to do a little bit of tidying up now. In effect, these would cancel. So on the right-hand side, all I'd be left with is 1 minus 3. I'd be left with minus 2. On the other side, so I've moved it over a little bit, I'm going to be left with two lots of x squared plus 4x plus 3. I'm going to, just to make things easier for me, divide by 2 on both sides. If I divide by 2 on both sides, that's going to give me minus 1 is equal to x squared plus 4x plus 3. If I add 1 onto both sides, that's going to give me 0 is equal to x squared plus 4x plus 4. Then I'm looking to factorise. That factorises really nicely. Two numbers that multiply together to make 4 and add to make 4, 2 and 2. So it's x plus 2 and x plus 2. So I've only got one solution. It's kind of a double root. To make one of these brackets 0, x would need to be equal to minus 2. So x is equal to minus 2 for that. 5 marks. Quite a nice question. For question 19, the first 5 terms of a sequence are 10, 17, 24, 31, and 38, right down the nth term of the sequence. So our first step is to look at the differences. Actually, this one's quite straightforward. We've got constant difference of 7, which means that the sequence must start with a 7n. And then what do we need to do to 7 to get to 10? We just need to add 3. So it's going to be 7n plus 3. Okay, question 19. There we go. Here is the first 5 terms of a quadratic sequence. Find an expression for the nth term of the quadratic sequence. So if I'm dealing with a quadratic sequence, I just need to give myself a little bit more working room than the question allowed. So if I look at the first set of differences, I've got a constant difference here of 8, 12, 16, and 20. And then if I look at the second differences, I'm looking at 4, 4, 4. So that means that my second differences are constant. So I would have a 4 over 2 n squared. Second difference, 4 over 2 n squared within my term. So my term sequence is going to have a 2n squared in it. If I then look at what 2n squared would give me, that would give me the numbers 1 squared is 1 plus times by 2 would be 2. 8, 32, 1, 4, I've missed one out. 1 squared, 2 squared, 3 squared would be 9, so that would be 18. Then I've got 16, 32. Then I've got 25, 50. If I look at the difference between that and the sequence, so the difference between that and the sequence was 9, 17, 29, 45, and 65. So we still need to add something on to 2n squared to get to the sequence. So if I look at the differences now, so the differences would be 7, 9, 11, 13, and 15. And if I were to describe that sequence, that would be the sequence, because we're going up in 2s, 2n plus 5. So my sequence is going to be 2n squared plus 2n plus 5. Okay then, question 20. For question 20, we're looking, below shows an isosceles triangle. Each side is measured in centimetres. Find the perimeter of the triangle. So for an isosceles triangle, these two sides are going to be equal. So in effect, I'm saying that 3x minus 1 is going to be equal to x plus 9. Then I'm going to have to look at solving that. So minus 1x from both sides and add 9 would give us 2x is equal to 10. So x is going to be equal to 5. From that, I can work out the size of each length. So 3x minus 1 would be 14. X plus 9 again would be 14. And then x plus 1 would be 6. If I add those three sides together, that would give me then 20, 34. and that's going to be centimeters. Okay, question 21, solve the inequality. So you treat this like an equal sign, add minus 11 from both sides first of all, so 2x has to be greater than or equal to minus 9. Divide both sides by 5, x would be greater than or equal to minus 9 over 5 would be 1 4/5, or minus 1.8. I'm going to leave it as x is greater than or equal to minus 1 4/5, although if you've got minus 1.8, that's absolutely fine. Okay, question 22 then. The region labelled R satisfies 3 inequalities. State the 3 inequalities. So I need to work out the equation of the 3 lines. The equation of this line would be x is equal to 2. The equation of this line here would be y is equal to 6. We've got a dashed line here that I'll talk about when we get to it. And then the third line here would be the equation y is equal to, it has an intercept on the y-axis of 6. And it has a gradient of, for every 1 square across, it goes down 6. So it would have, for 1 square across, it goes down 6. So it's got a gradient of minus 6, so minus 6x. So in effect, I'm almost at the point where I can write my 3 inequalities. I'm going to write those equations with missing out the equal signs for now. I forgot what I said there. 2, and then y, and then minus 6x plus 6. The region that satisfies all of them, I need to kind of think about whether it is greater than, less than, greater than or equal to, less than or equal to. For this line, it's going to be less than. So for this line, it's going to be a less than. Sorry, it's going to be a less than or equal because it's not a dashed line. This one is a dashed line, so it's going to be less than. And then the final line, I'm after the point where y is bigger than minus 6x plus 6, so greater than or equal to. So those are my 3 inequalities. Okay then, question 23. So the graph shows the depth of water in a container. Write down the gradient of the line. So the gradient of the line it's quite a nice one. I tend to say pick the larger triangle. The larger the triangle, the more accurate from a real life graph. But we can see that this is quite a friendly line anyway. But the gradient is going to be equal to the change in y. So if I've gone from 70 to 10, I've gone down 60. And the time has been 12. So the gradient of that line is going to be minus 5. What does the gradient of the line represent? So it represents the drop in depth each second. The change in depth each second. If we go in a bit more detail, what does the gradient represent? It represents, we could go further, a drop of 5, what was our unit here? Centimeters each second. Though. So 24, solve the simultaneous equation 2x plus y is equal to 5 and 2x squared plus y squared is equal to 11. When I'm solving one linear, one quadratic using simultaneous equations, I tend to convert one of them into either y equals or x equals. So I'm going to rearrange that to say that y is going to be equal to 5 minus 2x. So I'm then going to substitute y into the second equation. sub y into equation 2. So that would give me, instead of 2x, well no, not instead of 2x, 2x squared plus 5 minus 2x squared, which would be equal to 11. I've then got to multiply out that bracket. Again, there's nothing wrong with you taking a side step, so doing your working at the side. If you're not confident squaring a bracket, because I do it a lot, I'm fairly confident with it. It's going to give me 25 minus 20x plus 4x squared is equal to 11. Then rearranging that, that's going to give me 6x squared minus 20x. I'm going to minus 11 from both sides, so plus 14 is equal to 0. So all of those numbers are even, so I can cancel down by a factor of 2. So 3x squared minus 10x plus 7, which is going to be easier to factorize. So it is quite a complicated one to factorize, but to make a 3x, we can only have a 3x and an x, and then to make a 7, we can only have a combination of a 7 and a 1. We need to place it correctly to make minus 10 though. So if I go minus 1 there and minus 7 there, that would work, because that would give me minus 3 minus 7 would give me minus 10. So from there I get two values for x. Either x is going to be equal to 7 over 3, or, and I kind of split this up now, x is going to be equal to 1. So I'm going to get a pair of solutions. If x is equal to, I'll do the easier one first. If x is equal to 1, 5 minus 2, y would be equal to 3. Or y would be equal to 5 minus, let me just check that again, 2x. So 5 minus 2 times 1, so that would be equal to 3. If x is equal to 7 over 3, then y would be equal to 5 minus 2 lots of that. So 5 minus 14 over 3. Well, 5 is going to be 15 over 3, so that would be just 1 over 3. So that's my pair of solutions. And I write them as a pair. So it could be x is equal to 7 over 3 and y is equal to a third, or x is equal to 1 and y is equal to 3. 2 sets. So for question 25, in the diagram AB is parallel to CD. Work out the size of the angle measured as x. So to do that, you must show your working. It doesn't say you need to state your reasons though. I'm going to state that, first of all, this angle here is going to be equal to 180 minus 100, so I'll show it, 180 minus 116 is going to be equal to 64. This angle here is going to be equal to 180 minus 51 plus 64, because angles in a triangle add up to 180. So I'll bring my calculator in, first time in a few questions. 180 minus 51 plus 64. Missed out my 1 there. So that's going to give me 65. And then that's an alternate angle, sorry, a corresponding angle, so that angle x would also be equal to 65. So question 26, diagram shows the position of two aeroplanes P and Q, and it says not drawn accurately. The bearing of P from Q is 070. Calculate the bearing of P from Q. So in effect, I want a bearing which is a 3-figure. I want that angle. To make that easier for myself, what I'm going to do is I'm going to work out that angle. That's going to be called a supplementary angle. That plus 70 need to add up to 180. So that's going to be 110. Or if I'm showing the working for that, 180 minus 70 is 110. So the bearing is going to be 360 minus 110. So the bearing is going to be 250. So bearing is going to be 250. Okay, question 27 then. Using a ruler and compass, construct the bisector of the angle ABC. So I'm going to snip this into my snipping tool just because it's a better way of me showing it. And I can't quite use a protractor, but you can kind of get the idea behind it. So for this question, let me just make it slightly bigger. So for this question, then what I need to do is take out my protractor. For the purposes of a protractor, I'm not using a protractor, but you kind of get the idea. I'm going to be using a circle just because it means that I can produce the arc lines that you would produce with your protractor. You need to set your compass arms so that they are not any bigger than either of the lines. So I couldn't set my compass arms like that because I'd be arcing off the two lines. It needs to be big enough so that they arc onto both lines. When I'm set with my compass arms, I would arc onto both the lines AB and AC. From there, I can adjust my compass arms if I want to at this point, but for the next section, I need to keep them exactly the same length. So make sure your compass is quite firm. If it's not, ask for a tighter one from exam instructor. And what I'm going to do is I'm going to put my point on the arc line that I've just made on an AB, and I'm going to arc into the center. Then I'm going to keep my compass arms the same length apart, and I'm going to move my compass point to the arc line that I made on BC. I'm going to arc into the center, and the point where my two arc lines cross is my bisector of the angle. So I take my ruler, spin it round, and then I draw a straight line through the center of the angle, so at B, and then through the two arc lines that I've just drawn. There we go, and that becomes my perpendicular my bisector of the angle. It's not perpendicular, it's a bisector of the angle. And that's how I would do that question. Okay. Okay, for question 28, I'm going to struggle with this ever so slightly, but we'll give it a go. So this is as a section, I call this loci, I would imagine. Right, so you've got a diagram like this. The diagram shows two lighthouses. The boat is within 8 miles of lighthouse A. The boat is within 6 miles of lighthouse B. Shade the possible region which the boat could be in. I'm just going to kind of measure this on my diagram. I've got 1, 2, 3, 4, 5, 6, 7, 8. Arguably centimeters, arguably. On your diagram, it's going to be, I've just measured it on my A4 version, it's 12 centimeters. So I've got to imagine that gap there is 12 centimeters. So I need to set my compass arms to firstly 8 and then to 6. So if we kind of imagine, yours should look something along these lines. So if I set roughly, and you're going to have to kind of get the idea, if I set my compass arms to roughly 6, so I'm going to say that that's going to be 6 centimeters. I'm going to place that at A, and then the boat has to be within this circle. So the boat has to be within this circle. Technically, it's not going to be on the land, but you get the idea. And then I need to set my compass arms to 6. So if I reduce them a bit, you can kind of get the feel for the question. So I'm going to say that's about 6. And then I do the same from B. I would arc. And then technically my section that is within both of those circles, we can't really have a boat on land. So it's going to be that section there. Yours, if you do it accurately, is going to be slightly bigger than mine. But you get the idea of the question. The idea of the question. Okay then, we'll move on to question 29. So the front elevation of a solid shape is a circle, the side elevation of a solid shape is a rectangle, and the plan view of the shape is a rectangle. Write down the name of the shape. So front elevation is a circle, side elevation is a rectangle, and the front elevation is a rectangle. The only shape that could fit all three parameters is going to be a cylinder. Okay then, question 30. The area of the trapezium is 34 centimeters squared. Work out the value of x. So we will use a calculator for this, but I'm going to start by the area of a trapezium is going to be a half of a plus b times by h, where that value is a, that value is b, that value is h. So if I substitute in what's known, then 34 is going to be equal to a half of x plus 6 times by 4. And then I kind of need to rearrange to solve. I'm going to do a half of that is 2. 34 divided by 2 is going to be 17. So 17 is going to be equal to x plus 6 minus 6 from both sides. 11 is equal to x. And question 31. James has a bicycle. Each wheel has a diameter of 45 centimeters. James cycles his bike in a straight line in the playground. The front wheel makes 15 complete revolutions. How far does the bicycle travel? So if the diameter is 45, then the circumference is going to be equal to pi times by d. So in this case, the circumference of the wheel is going to be 45 pi. We want to know how many times 15 revolutions of that is going to be. So 15 times by 45 pi. It doesn't ask us to leave our answer in terms of pi, but that would give me 675 pi. But that is going to be in meters. That is going to be in centimeters. So if we want to convert that into meters, we need to divide by 100. So 675 pi divided by 100 to convert it into meters is going to be equal to 27 over 4 pi, and then that as a decimal would be 21.20575. So if I go 206 to 3 decimal places. Okay, moving on to 32 then. So the logo is designed that has 4 pink circles within a white square. The square has sides of length 16. Find the area of the logo that is white. Well, if we've got 16 here, then it means that the radius of each circle is 16 divided by 4, so it would be 4. So in effect, what we would need to do is 16 squared, the area of the total circle, and from that I'd need to subtract 4 lots of the area of the circle. So 4 times by pi times by 4 squared. And I wouldn't really go any further than that. I'm just double checking in my head. So I'm going to say that that's going to be 16 squared minus 4 times by pi times by 16 squared. So that gives me a value of, which does not make sense. So for some reason I've typed that in as 16 squared and I've written it as 4 squared. So there we go. That's what I was looking at. I've obviously got a mistake there. So I'm looking at 54.93807. So ... Find the area. So I'm going to give it as 54.94 to 2 decimal places. Okay, question 33. Calculate the perimeter of the sector. So the perimeter of the sector, first of all, I'm going to work out the arc length. So the arc length I'm going to call AL. The arc length is going to be equal to 284 divided by 360. So the fraction of the circle that we've got times by the circumference of a circle, which is 2 pi r. So 2 times pi times by 4. So in effect, to that, now I'll work that out first of all. So I'm going to go fraction 284 over 360 times by pi times by 2 times by 4. So I get the perimeter of that shape, sorry, the circumference or the arc length as being 284 over 45 pi. So I want the total perimeter. The perimeter is going to be the arc length plus 2 lots of 4, that 4 and that 4, so plus 8. If I add 8 to that value as a decimal, I would have 27.8269 dot dot dot. So I'm going to give it as, doesn't ask for a degree of accuracy, I'm going to say 27.8. I'm going to go 83 to 2 decimal places. For question 34, still looking at sectors. The area of the sector is 38.4 centimeters. Find the size of the angle. So for area of a sector, let me just bring that back. So area of a sector is equal to, let me bring my calculator up. So it's going to be equal to the angle divided by 360 times by pi r squared. So if we're told that the area, I'm going to rearrange that now. So I'm going to say that the angle, and there's nothing wrong with you not doing it right now, is going to be equal to 360 times by the area of the sector, and I'm dividing that by pi r squared. So if I then substitute in, I'm looking at 360 times by 38.4 divided by pi times by 9.2 squared. So on my calculator then, 360 times by 38.4 divided by shift pi times by 9.2 squared gives me the value of 51.988. So I'll write that in full. 51.9886 dot dot dot. To 2 significant figures then, that's going to be 52 degrees. Okay, 35. Below are 2 triangles ABC and BCD. Find the length of X. So we're asking to find this length. We need to use Pythagoras to find out that length first of all. So I'm going to call that length Y for now, although you can letter it however you want. So I'm going to say that Y is going to be equal to the square root of 6 squared plus 7 squared. In theory, I'm going to take, no, I'm going to change that slightly. I'm just kind of pre-planning my next step. I don't really need to find Y. What I need to find is Y squared. So I'm going to leave it like that. So Y squared is going to be equal to 6 squared plus 7 squared. So that's going to be equal to 85. So Y squared is equal to 85. For the second bit then, to find X, again, I'm finding the hypotenuse. So X squared is going to be equal to the square root of 11 squared plus Y squared. And we've already got Y squared. So X is going to be equal to the square root of my answer plus 11 squared. So it's going to be the square root of 206. So as a decimal, that's going to be 14.3527. So I'm going to give my length as 13.35 to 2 decimal places. Okay, and question 36. The diagram shows two right-angle triangles. Calculate the value of x. So similar question to 35, except we're having to use trigonometry here instead of Pythagoras, but it's kind of the same principle. So I'm going to work out this length first of all, which I'm going to use to find my value for x. So if I'm starting with y, this is my angle, so this would be the opposite and this would be the adjacent. The tan, so the trig ratio involving an O and an A is the tan ratio. So tan is equal to opposite over adjacent. The version that we want is to work out the opposite. So if I rearrange that, the opposite is going to be equal to tan times by the adjacent. So y is going to be equal to the tan of 50 times by 5. I'm going to kind of leave it like that for now. Then if I'm working on the second triangle, this would be the opposite and this would be the adjacent again. So I'm using the same tan ratio. So for that one, O is going to be equal to tan of the angle times by the opposite, no, times by the adjacent. So I'm going to just type this in once then. So x is going to be equal to the tan of 38 times by the adjacent, which is y. So y was tan 50 times by 5. So I can just get away with typing that in once into my calculator. So the tan of 38 times by the tan of 50. Help if I type it in right. 50 times by 5. That should give me 4.655499 dot dot dot. Imply I haven't rounded. I'm going to go 2 decimal places again, so 4.66 to 2 decimal place. Okay then, question 37. Translate triangle A by a vector of -3, 1. So I'm going to pick a point to move. I'm going to move that one for, well, that one. And I want to move it 3 to the left and 1 up. So if I move that 3 to the left and 1 up, so that point is going to move to there, and then I just draw the shape there. For 38, describe fully the single transformation that maps triangle A onto triangle B. So I'm looking at it, it is, interesting. I think you could get away with 2 descriptions for this. There are occasions where that happens. I think I could describe it as either a reflection or a rotation. So I'm going to describe it first of all, or arguably a negative enlargement as well. Yeah, I think you could get away with 3 answers here. The first one is going to be a reflection, 2 marks, so it implies that it's the reflection one. So I'm going to go reflection in the line y is equal to x. Help if I write that right what I say. Reflection in the line y is equal to x. Although, arguably you could have got away with a rotation of 180 degrees about the point -1, -1. That would have been acceptable, I believe. And then finally, you could have gotten away with enlargement, scale factor of -1 about the point -1, -1. All 3 of those answers would be acceptable. I would, looking at the question, because it's only a 2-mark question, I would imagine, well, the answer that they're looking for is a reflection in the line y is equal to x. But the other 2 are acceptable. Okay, describe fully the single transformation that maps A onto B. So if I'm looking at that, I'm going to say to go from that to that, I'm going to rotate it. So it's going to be a rotation. A onto B, I'm going to rotate it 90 degrees and clockwise. 90 degrees clockwise. Then I'm looking for the point of rotation, and to do this you might need to get some tracing paper out if you're not particularly confident. I'm looking at I tend to try and find a point where I can, so that would actually work. So it's about the origin. Okay then, question 40. Enlarge triangle by a scale factor of -1/2 using a centre of enlargement of 2, 0. So first important part is to mark on the point of enlargement. So 2, 0 is going to be that point there. So if I'm enlarging by a scale factor of -1/2, if I look at one point in particular, that point is currently 2 squares away from the point of the centre of enlargement. So if I times 2 by -1/2, it becomes -1. So that point would move to there. And then I could do that for each shape if I wanted to. This point here is 2 to the right and 4 up, so it would go 1 to the left and 2 down. And then if we look at a final point, this point here is 2, 4, 6 across, 2 down, so it would go 3 across and 1 up. So that's going to be my negative fractional enlargement. Okay, 41. Mrs. Hampton is potting plants. She is using 2 mathematically similar pots. The smaller pot is 10 centimeters tall and the larger pot is 14 centimeters tall. She has 2 bags of soil, each containing 30 liters of soil. With the first bag, Mrs. Hampton fills 20 small pots using all of the soil in the bag. How many large pots can be filled completely using the second bag of soil? Okay, so I'm going to first of all work out the volume of each pot, of each of the smaller pots. So the volume is going to be equal to 30 litres of soil will fill 30, so it's going to be 30 divided by 20, so each pot will hold 1.5 litres of soil. The next thing I want to look at is the scale factor. So to get from there to there, I am timesing by 1.4, because essentially it's 14 divided by 10. So that's the length scale factor. So the volume scale factor is going to be that cubed. So each of the larger pots is going to hold 1.5 times by 1.4 cubed. So each large pot will hold we'll go for that value. Actually, that will give me a fairly decent decimal. Each large pot will hold 4.116 litres of soil. The second bag is 30 litres. 30 divided by 4.116 will give me the number of pots she can fill with that. So 30 divided by the answer that I just worked out gives me 7.288629. So she can completely fill 7 pots, 7 of the larger pots. Okay, question 42. Triangle ABC has length AC is 15. Angle ABC is 112. Angle BAC is 33. Work out the size of BC. So BC I'm going to call X for now. This is a non-rectangle trig question involving 2 sides and 2 angles. So we're using the sine rule. So And I'm going to put it in the format that's going to be most useful to me. So I'm going to try and say, my pen's overloaded and stopped working. We'll see if we can get it back. So I'll go to my backup pen. Let's see if that works. There we go. So x over the sine of 33 is going to be equal to 15 over the sine of 112. So rearranging, then x is going to be equal to 15 sine 33 divided by sine of 112. So that's going to give me fraction button 15 sine of 33 close bracket sine of 33, 15 sine 33 over sine of 112. So assuming I've typed everything incorrectly there, I'm looking at x being equal to 8.811181 ... to imply I haven't rounded. So I'm going to give that length correct to 2 decimal places, so 8.81 to 2 decimal places. Okay, question 43. Again, we're still sticking with the topic of advanced trig, or trig for non-right angled triangles. Calculate the length of BC. So I'm going to call that x for now. And we're going to be using the cosine rule here. So in effect, x squared is going to be equal to 23 squared plus 20 squared minus 2 lots of 23 times by 20 cos of the angle. And it's just a case of typing that into my calculator. So 23 squared plus 20 squared minus 2 times by 23 times by 20 times by cos of the angle, so cos 55, and provided I've not made any mistakes in typing that in, which I have, there we go, minus, I missed out my 2. Provided I've not made any mistakes, I get cos of the angle is 401. X squared is 401.309 ... to show I haven't rounded. So x is going to be equal to the square root of that. So square root my answer gives me 20.0327 ... So I'm going to go 20.03 again to 2 decimal places. Okay, 24. So again, just as a guess, before we even read the question, we've done using the sine rule, using the cos rule. This, I would imagine, would be an area one. So calculate the area of the triangle. Yeah, so we're looking at the area being half of AB sine C. So in this case, we could argue this, we could work out sine of 60. I think that's going to be root 2 over 2. But it's the calculator paper, so there's no point, times by sine of 60. So let's type that all into our calculator. So 1/2 times by 6 times by 7 times by sine of the angle gives me my area as 21 root 3 over 2. So as a decimal though, that's going to be 18.18 18.186533 ... So I'm going to give it to 2 decimal places again, so 18.19 to 2 decimal places. Okay then, and 45, DFG is a straight line. We're told DE is 4A and EF is 6B. Write down the vector of D to F. So D to F is going to be equal to 4A plus 6B. And then you're told D to F and F to G are in the ratio of 2 to 3. Work out the vector of D to G. So in effect, if I just look at this, if we're told D to F, F to G is in the ratio of 2 to 3, then in effect that means that 3 lots of DF are going to be equal to 2 lots of FG. So in effect, if I wanted to work at FG, so FG, no. Oh, okay. So, yeah, if I wanted to work out FG, then FG is going to be 3 over 2 times DF. And we've already worked out DF. So that is in effect 3 over 2 times by 4 is going to be 6A. And then 3 over 2 times by 6B is going to be 9B. And then D to G is going to be equal to D to F plus D to G, sorry, plus F to G. So in effect, I'm adding this and this together. So that would give me 10A plus 6 plus 9 would be plus 15B. So 10A, I've written plus twice. So let me just tidy that up a little bit. So 10A plus 15B is going to be my answer for that. Okay, and then question 46, work out 3A minus B. So I'm going to write this as, I'm going to write down 3A first of all. So 3A is going to be 9 times 3 is going to be 27. And then 3 times 6 is going to be 18. And from that, I need to subtract 4 and I'll put it in a bracket for now, and minus 1. So 7 minus 4 is going to give me 23. And then 18 minus 1 becomes plus 1, so it would be 19. And I'm going to stop the recording there. So I've been doing this as a live paper with my year 11s, and we've just about run out of time. We've done a good amount, 46 questions. Thank you very much for your time, and good luck with your exam tomorrow. Please feel free to add any questions to the thread. Subscribe if you like, and I will see you soon.